I bought like $1,000 question, like right this.
This is it.
Bag, like, it's like my best presentation.
Wherever you want.
I sure it's the my CV.
Not get some of these notes, but I mean, just stop
It's a medical care. So I do have a, I do. Oh, this, I'm not sure where. I'm not sure where. I'm like, I'm too often gamble today. My advisors. So they're
Hello, everybody. Welcome to the MLS BOF. We're going to start in about 2 minutes. So who in the audience would like to volunteer to take the notes? Okay. We have a volunteer over there, Nadeem. You can stay where you're at if you'd like.
By the way, very entertaining lightning talk in SAG. Do we also have a Jabber scribe? Somebody in? Excellent.
Thought there'd be more.
All right, let's do it. I see you.
All right, so as our new area director arrives, I'd like to welcome everybody to the Messaging Layer Security BOF. If you're expecting something else, or if you're in the other room, no, this is the right room. So today we're going to go through several presentations and talk about a proposed charter for messaging layer security.
So here's the note wheel. It's Thursday. You should have seen this a bunch. So we're not going to linger on this very long, but it's in the slides if you really want to read it. We got a minute taker. We got a Jabber scribe. Please sign the blue sheets as they're going around. If you're not already subscribed to the mailing list, it's there. And the Jabber room is also listed on the slide.
All right, so this is the overview of the agenda. We're going to start with a bit of agenda bashing. If anybody has any changes they want to propose, as well as following that, we're going to do a 30-minute problem statement, followed by an architecture presentation, a protocol draft presentation, as well as a state of formal analysis. And then we're going to spend most of the remainder going over the charter text very closely. And we'll end it off with some BOF questions. So we'll try to keep this moving rather quickly, and if people get behind, we'll let you know.
So just so no one's surprised, they are the typical BOF questions. So if you've ever read the RFC on how to run a successful BOF, we just copied them. So there's no surprises, and we don't have to argue about where the words go in the sentence. Okay, so first up is Richard.
All right, thank you, chairs. Thanks everyone for being here. So
Wanted to give everyone an overview of why we're here today, the group of us who proposed this, why we care about this, what problem we're trying to solve. Next slide, please. So if you look at the App Store, any App Store really, and look at for secure messaging apps nowadays, you get a bunch of them. I think we've got people who work on most of these here today, actually. A lot of these are using really similar protocols. Variants on Signal protocol are especially prevalent. Some of them are using super different things. Cisco Spark, there in the left column, and iMessage use pretty different protocols. But what's common about all of them is that they're uncommon. They're all using different protocols, maintaining their own libraries, their own software. And because all these protocols are different, they have independent security analyses, and some of them have gotten very thorough security analyses in academic papers, and some of them have no analysis at all that I know of anyway. And so the goal of this, well, next slide, the goal of what we're doing here is to kind of address that situation. The concrete target we're after is an asynchronous group messaging security protocol. We'll dive into unpack that on the next slide. But the idea is to get something that can meet the needs of all those apps that were on that last slide and more, and other applications that have these common use case in common. Now, to put a little finer point on that, there's a couple of aspects of interoperability we are after and some we aren't. So the impact of these specifications that we're trying to get here, I'll skip to the bottom and say that we're not trying to get full interoperability between messaging applications. That's a much more complicated question involving message transport, involving how you express application level notions, what you put in a message. And what we're after here is really just that crypto layer. So getting a crypto layer that's specified closely enough that we can generate code that's reusable in multiple contexts, and have security analyses that can be used to underpin these messaging applications. So the analogy here is that there's tons of applications that use HTTP, that use TLS and use TLS in different ways. And so the idea here of MLS is to design a messaging security protocol that can be used in many different applications in many different ways. And what you'll see in these documents, the architecture will discuss kind of our general architecture for a message, how we imagine a messaging protocol, and how MLS can fit into that context. And then the protocol document will describe the draft of what we got so far. Yeah, DKG.
Hi, Daniel Kahn-Gilmore, ACLU. So just as a clarifying question on this slide, you mentioned that application level interoperability is a non-goal. This does not address single application with multiple, say, servers or federated communication. So I just want to be clear that federated communication, like cross-server domains or things, is also out of scope for this.
I would say so, yes.
Okay, just wanted to make sure that that's clear too, because it seems like that would be a relevant point, right? We have XMPP already, for example, and we're not trying to do that.
That's correct, yeah. I think probably we want to be compatible with use cases like that and not block that. I think Dave Cridlin, if he's in the room, has already been thinking some about how to address XMPP. But I think that's something it's not kind of a primary goal. Echo, yeah.
Yeah, I mean, from my perspective, XMPP has like no authentication structure really at all, other than like it's on, other than on the same server, right? So you need it. But I mean, if somebody were to layer an authentication structure on top of XMPP, then you would imagine everybody who would like adhere to that would be able to talk over XMPP with federation.
Yeah.
I think the case I think that is like not really in scope at all is like people have their own disjoint like authentication and any infrastructure is talking to each other.
And I really, I think that a lot of where federation will become an issue for this protocol is in the authentication layer. And that's, I'll speak a bit more about authentication later. Let me just table that for the moment. So next slide, please. We'll unpack the concrete substantive thing we're after here. So we've got a few components to this description. So whatever protocol we get here, needs to have this asynchronicity property. And what that means is we want to be able to have these secure messaging sessions where no two participants are online at the same time. So if I'm starting up a chat with Imad, I should be able to get some information that he's cached in the cloud and start up a conversation with him and send him messages that are secure with regard to everyone but Imad. And then when he comes online, he can get those messages, perhaps update his key and respond to me without me being online. And then when I come back online, I can download those and read those messages, etc. And that applies to both messaging, as I was talking about just now, as well as changes to the group, adds, removes. And that kind of goes into the next one. So this is more than just a one-to-one protocol. So TLS, the case we've had the most experience with in the IETF, is explicitly a one-to-one protocol. There's a client and a server. And the use case we're after here is groups. There are some protocols that have been really well vetted in the one-to-one space. And I think a lot of what this is, and I'll mention this later, is to kind of generalize some of those lessons we've learned from those protocols to make them work better with groups. Yes, please.
Hi, Dave Kemp. You say support sessions. Does that imply that there's state carried over time and there's an end session primitive to this? Or is it really like messaging where each message stands on its own?
At least in the drafts we have now, there is a notion of continuity of a session. And I think maybe I'm looking over at Catriel, our academic friend here. I think some of the goals we have around post-compromise security probably depend on carrying that state. I don't know, we need to discuss it a lot, but yeah, right now we do have that notion that there is a group and there's a conversation that evolves over time and it is correlated and there's a state that gets carried along. Yeah, thanks for the question. So yeah, we're supporting groups here. It's not just one-to-one, and we have a goal to support large and dynamic groups. So obviously we need to be able to add people to groups, to build the groups, and remove them over time. And in addition, a lot of the reason we need to look at a group protocol as opposed to just using a whole bunch of one-to-one channels is that there's a bunch of messaging applications that need to support large groups. So I feel like the number goes up by an order of magnitude every time we have a conversation about it, but it's in the kind of thousands to hundreds of thousands of members range. And here by members, typically we'll be talking about individual devices, individual private key holders. So pretty large groups. And you can imagine, if the scaling of your protocol is linear, at that sort of scale, it gets to become kind of difficult to do 100,000 DH operations to add someone, say, or things that are quadratic that might work at small scale get really difficult at the scale of once you add some zeros. So large dynamic groups and try and address those pretty efficiently. Now let's talk about the security properties we're trying to get. And I've got a cartoon on this in the next slide. There's a few major security properties we're trying to get here. Obviously, we want message confidentiality. That's kind of why we're doing this whole thing to start with. But within that, we want that confidentiality properties to have two properties in terms of its evolution over time. So to go to the question earlier, we want forward secrecy. So, in the sense that if there's a compromise, then past conversations are secret. And we also want post-compromise security. And this will be a less familiar notion of folks, in the sense that if there's a compromise, then at some point, future messages are also going to be secret from the attacker who had a point compromise. Well, I'll dive into that a little bit more on the next slide. Authentication is a concept that's going to be critical here so that we know who we're encrypting to, who can read these messages that are confidential, what the boundary of the confidentiality is. And finally, there's some explicit non-goals we want to call out here that have been properties of some protocols in the prior art. Deniability is one. I've said full-time deniability here because we may want to have some deniability, but we know we need a non-deniable option for several cases that we've talked about. If you look at some of the existing cases. Malleability, again, transcript forgeability is a property that some of the prior art has that at least among the discussions we've had so far has not been a requirement.
Can you expand on what those two properties mean?
Say again?
Can you expand on what those two, I don't know those terms.
Deniability, Karthik, would you like to comment on this? No, okay. I think what we mean here is deniability means to be able to, no, Ecker?
Yeah, to be able to claim that the message that was sent wasn't yours. And better for not to be possible for someone else to prove that you sent a given message or that you engaged in a communication.
Yeah, kind of the opposite of non-repudiation.
Malleability?
So it's technical stuff we don't want to get into.
You don't want to do it and you can't
It's kind of the opposite of integrity. After the fact, All right, the next slide kind of is a cartoon of what we mean. The topics, the properties we'll talk about most are forward security and post-compromise security. And this is a cartoon of what we mean by that. So both of those properties are addressed as a point compromise, the assumption that an endpoint is fully compromised, all of its secrets are published to the attacker at a point in time. And the idea of having forward secrecy and post-compromise security properties in a protocol is that there are some protocol actions that establish these boundaries. So in TLS, you get forward security when you do a new handshake with a fresh DH exchange, because the fresh entropy from that DH exchange cuts off anyone who had the secrets to the session in the past. So that would be kind of the left-hand boundary here, if you're thinking about this in a TLS sense. Post-compromise security is kind of similar. We also address that with kind of adding fresh DH entropy, but here it's kind of you have the endpoints keep around some state that they can use to update over time and add fresh DH entropy as the group moves forward to kind of lock out past versions of themselves.
Sorry, this is DKG again. I actually think that your explanation of forward security was incorrect, and it may have just been a slip. Okay. But I think it's easier to think of forward security in a messaging context as deletion schedules. What gives you forward security is not that you created a new DH pair, or even that you ratcheted forward a secret, but that you destroyed the prior secret. That's what gives you the forward security. The destruction of the old secrets, not the new stuff.
Well, it's a combination of both. You need
if you destroy the old secrets and you don't create the new stuff, then you can't keep talking, right? But the destruction is what gives you the forward security.
Yeah, you need to transform the group state to something that's inaccessible to people that have the history, and then delete the history. Yeah, absolutely. So next slide. Yeah, I just wanted to call out the prior art here for comparison. There's been a bunch of work on this in the past. I won't go through the specifics. I think the important thing to take away here is that, the more recent stuff which is closer to the bottom. There's been a lot of good work on ratcheting protocols that do really well in the one-to-one case and demonstrate how to do asynchronicity and how to do PCS, but don't really scale well when you're trying to do larger groups. And so I think when you look at the protocols we sketched out that are in the draft, you'll see that they look a lot like these earlier ratcheting protocols, but they try and compress some state down so that they can do more efficient operations for groups. Next slide, please. So yeah, this is just kind of a cartoon of what we mean by ratcheting. Show of hands, people have heard of ratchets in the crypto sense? Okay, good. So this is a pretty familiar idea. So we generally talk about two types of ratchets. The left-hand side shows hash ratchets, which are forward security things. So as DKG was saying, if you derive things forward in time by hashing and you delete the old things, then you can't go backwards in time and get earlier secrets. And on the right-hand side is what we'll call a DH ratchet, where you update the keys you're using in a DH exchange over time. And that gives you post-compromise security with regard to older DH keys. And again, you have to delete the old things as well in this case to get PCS. The one other concept, so these are kind of the tools we're using from the prior art to get some of these properties. The other thing is that we're kind of pulling from the prior art is this idea of init keys, or pre-keys a lot in the literature, which are things that I can publish in the cloud that allow someone to initiate a conversation with me. They provide a public key and some related information. Someone can use it to initiate a conversation with me and begin sending me messages without my being online. So that's going to be kind of the key to getting asynchronicity in a couple senses. We're going to have some user init keys and we'll have group init keys. John will talk about that more when we talk about the protocol later. Next slide, please. So this just to kind of sum up. This is a cartoon of the scope I talked about earlier. So, by analogy to TLS here, as I said before, there's lots of applications out there that use TLS, HTTP, SMIME, or not SMIME, SMTP, XMPP, etc. And they're running over different transports. TLS, if you incorporate DTLS in this picture, they're transported in different ways. They might be transported in HTTP for those of you who came to the ATLS talk discussion earlier this week. There's different transports. You can transport these security protocols different ways, and they carry different things. But there's a common security layer that addresses I want to have a secure connection between a client and a server use case. And similarly, off to the side there is a relatively generic authentication function built into TLS where you can plug in a certificate and you can do a signature to create a certificate verify message. that authenticates the holder of a key pair. But the details of the PKI that get used with TLS aren't specified in TLS. There's just that clean interface point. And so I think that kind of encapsulates what we're trying to get at here. So we want a security protocol that can serve this group messaging function, kind of independent of transport and independent of exactly what's being carried in those messages. And also have this interface point over to some authentication scheme so that we can take different authentication schemes and plug them in a way that gets where we know something about what security properties we get. So we need to define that interface well enough so that we can talk about its security properties without wedding ourselves to a whole detailed authentication infrastructure. I think that's my last slide. Yeah. Questions on the problem statement? Thank you for the clarifications we've had so far. All right.
Yield the remainder of your time. You're 15 minutes ahead.
Hi everyone, I'm Imad Umara. I'm the tech lead for comms and WebRTC security in Google. So we'll talk about MLS architecture, covers the system overview and functional security requirements. So this is basically any messaging system what you expect to be server side and client side. So server side has authentication and delivery services. Most of the time they are operating under the same entity, but they are logically separate. Client side have a bunch of users. Each user maintain one or more device like web, desktop, mobile. From the protocol perspective, each device is a separate entity, separate client. So in this picture, we have like four members, A, B, C, and D, and there is a group between A, B, and C. A has 3 devices, B has 2, and C has 1. Next, please. So authentication services basically provides mapping between user IDs like email or phone numbers to long-term identity keys. Delivery services, it ensures in order and reliable message delivery and attachment. And if there's any reorder in the message, the client should, or the protocol should be able to detect that. And also store and retrieve user init keys. This keys used to create send first message with, or establish a session with the user without being online. And these init keys are signed by the long-term identity keys. And asterisk stores group membership. So MLS by itself doesn't require the application or the server to store the group members. However, the server can always know this by doing like some traffic analysis. So some application might just end up storing the group members at the server. And one last thing, the server is also responsible for evicting long-term inactive users. This to protect forward secrecy. Like most applications today using like 30 or 45 days. And after that, they just evict user or clients from the conversation. Next slide, please. Okay, so user will do what you expect them to do in any messaging system. They register, create group, send, receive messages, invite, remove members, join or leave existing groups, or add, remove devices. From the protocol perspective, invite, remove members, add, remove devices, they are the same. Device at the end of the protocol is just a single client. So at the protocol layer, they are the same operation. And at the protocol, all clients are peers. So anyone can add or remove any other one. The ACK-link for this operation will be up to the application layer. So in this situation, like A1 will try to create a group with B and C. So A1 will request init keys for A2, A3, B1, B2, and C1, create shared secret, verify the signature in these init keys, create shared secret, and encrypt the message and send to B and C. And B and C will calculate the same shared secret, decrypt the message, and optionally will trigger new key derivation to improve forward secrecy. Next slide, please. Okay, functional requirements, scalable. So the protocol should be able to support larger group up to 50,000 clients. Asynchronous, we should be able to start all user operations without the need for all clients to be online. And of course, multi-device. And because, as I mentioned, device are represent a separate entity, so multi-device will be supported natively. However, when you add a new device, you will not be able to access the previous conversation history, but it's always up to the application to support this. State recovery. So if any device or any client lost the state, should be able to recover it without affecting the group state. Metadata collection. This is to protect user privacy. So authentication service or delivery service should only collect the minimum metadata to deliver the message. Federation, as Richard mentioned, so we don't expect full interoperability at the application layer. However, at the protocol layer, different implementation should be able to interoperate. So far, go ahead. You want to use the mic?
Could you clarify whether state recovery is speaking about on-device state or server state?
No, in device states. Like, for example, the application crashed before updating its state, so it should be able to recover from this. Device.
Paul Wouters. So if I have multiple devices and you said that they are roughly equivalent to multiple users, their operations are the same, then aren't you already leaking information about when I'm answering from my mobile phone or from my smart TV at home?
Yes, this is a privacy concern concerning this issue, but I believe most of the protocol today to support multi-device have the same issue. However, there is some tricks you can do with specific for art, for the tree structure. You can actually work around this. For one example, John can talk about this more in the protocol, but one idea of this to have all devices under the same node. So from other users can only see a single node. You don't know how many devices you have.
Okay.
But this is a problem with any protocol today.
The problem is in scope.
Yeah, this is DKG. I was going to actually ask the same question. It seems to me like this is not actually a requirement, given the one device fan, like doing its own internal fan out.
I guess what I mean by the requirements here, because we want every device has its own identity key. This is why I say it's separate client. So because some applications require all clients under the same user share the same identity key.
Let me propose a distinct way to phrase this requirement. It must be possible to build a system in which people do not share data between devices, but rather have the devices independent. I'm sorry? Yeah, that's as Martin said, it's a caveat. Like, it's like really, really hard to get it's really, really hard to get that cryptographically. It's easier to get it with as an application. I mean, so we just concluded it was too hard to like really make it work with the crypto.
Ben Schwartz. I think it would be nice, at least, if we could entertain a requirement to be able to do this without knowing who the members of a group are. And I suspect that a blind signature scheme where you can, which would allow you to decouple the fact that somebody has an account on the system from the identity of the person in question.
Authentication entirely.
Yeah, the problem is the authentication. Like, but I wish, yeah.
John Lennox, is there assumption that there is some server that has a canonical notion of who is and isn't in the group and tells other people, or is there some possibility of a distributed groups where different group members have different notions of who's in it?
So you basically know, you're asking about if the client maintains the membership of the group or the server maintains the membership. So go ahead.
Yeah, no, I think one of the security properties that we're after here is that all participants in the group have the same notion of who is in the group. And so that's a property we want to assure independent of the server.
Which is interesting from a security point of view.
Really? You want everybody to know who's in the group? Sorry, Philhan Baker. In my applications, I want to be able to join somebody to a group and have them participate without knowing who else is in the group.
Well, as I mentioned in my previous slide, with membership asterisk, the MLS doesn't require the server to store this. However, some server might choose to store this. Like it's up to the application. So, but at the protocol level, it doesn't care. Okay, so far so good. Last point, versioning. Let's make things more complex. So yeah, MLS should support multiple versions, and it should make sure that picking the highest supported version between all clients, and of course have mitigation for downgrade attacks. Okay, next slide, please. Okay, security requirements. So message secrecy. Only a group member, current group member, should be able to decrypt and access the messages. Integration and authentication. Message should only be accepted if it was sent from existing group member. Again, another asterisk is we could optionally improve this by adding padding to the message to make it hard for traffic analysis. For secrecy, as Richard explained earlier, so means if an attacker have access to all the encrypted traffic and current key material, they should not be able to decrypt message older than the oldest key the attacker have. And post-compromise security, it's the other way around. So if an attacker has existing key material at time t, and this key material is updated at time t prime, the attacker will not be able to decrypt any message after t prime. Group membership security. So all clients should have the same view of group member. They could use like something like Merkle tree to achieve this, something like that. Added client should not be able to access previous message before joining the group, and the same for remove the client. They should never access to the message after they leave. Attachment security should have the same properties for messages, except the encryption keys for the attachments tends to have longer lifetime because of the bandwidth user tends to download this later. So they might have a weaker PCS property. Data origin authentication. This means no other client can impersonate any other client in the conversation. So IS can send messages that appears coming from Bob. This will require adding a signature for every message. And another asterisk is deniability. So it's very painful. So I know. So the MLS by itself, as Richard explained, it doesn't require deniability. But so particularly when it comes to deniability, there are 4 camps. First camp, I don't understand deniability and I don't care, which is easy. Second camp, I understand deniability, but life doesn't work this way. All I need to do is just a screenshot of the application to prove the sender of the message. Still easy. Third camp is the opposite of deniability. I don't need deniability. I think I need a crypto proof for the message sender. And fourth camp is the people who really, really care about deniability. They think it's awesome. They can't live without it. So it's hard to make everyone happy, but it would be great if the protocol can optionally support deniability. This will come up with the cost by exchanging. So we can't sign by using identity anymore. So if the deniability mode is on, this means every user has to exchange new signature keys over the deniability channel. Yes.
Yes. Maybe it's too early to discuss this, but just. Oh, sorry. Yes, I've been complaining about people not doing that because I can't note it down. So you're absolutely right. I'm Nadim Kobaisi from INRIA. So on the previous slide, you mentioned versioning, and I'm afraid it might be too early to discuss this, but we should probably just have it in our minds. So there's versioning, which is good, but at the same time, we seem to be adopting versioning and cipher suites at the same time in the protocol, because we have versioning, but at the same time, we also have Curve 25519 and P256, and we can choose between the two. Is my understanding correct?
In the current draft, yes.
So it seems that it might be wise to attempt to limit the amount of state malleability and maybe only rely on versioning in terms of which ciphers are adopted, instead of having both versioning and also within the same version the ability to switch between multiple ciphers, especially because, for example, Curve 25519 does not require input validation for Diffie-Hellman, while P256 does.
I generally agree with you. The problem with this, some application might be deployed in different devices, and some devices has different hardware implementations. We prefer like some different crypto implementations. But I generally agree. If I don't know, Eric has something to say.
Okay. Well, Eric was I was going to say is this is probably not the time to discuss this point.
Yeah.
Yeah, we haven't discussed agility or crypto primitives yet, so we'll save this for later.
Okay.
I meant like after the working reform.
Yeah.
Okay, that's a good answer. It's too early to ask. I will do this every time. Okay, next one, please. Oops. Okay, security consideration, the good, bad, and the ugly. So, delivery service compromise. This should be good because the server should not be able to decrypt or access any of the messages. However, it can try to modify or reorder the message, but the protocol should be able to take this. And of course, it can always do DOS attacks. Okay. The bad, authentication service compromise. This can return, because this is bad because it can return incorrect credentials. This will allow impersonations, and it can only be defeated by the guy who's going to ask the next question. So, or transparency logging, which is key transparency. The ugly is client compromise because the attacker can actually read existing message and send and receive messages. However, it should not be able to DOS the server or peers, and this will be defeated once the key material is updated. I guess this is my last thing. So if you have a question, please go ahead.
Yeah, so this is DKG again. So this is a description of what we expect the attacker to be able to do, right? Yep. But my understanding is that this draft does not attempt to define the actual delivery service mechanism or the authentication service mechanism. Is that right? Or do we also intend to define a specific authentication service mechanism? Or do we just say, I think as the earlier slide deck said, clean interface goes here, figure it out for yourself. Are we trying to actually specify what that interface is?
I think at least for the authentication service, it's out of scope. I'm not sure about delivery service. Richard might take this.
Yeah, I think that's right, DKG. We are trying to, I think this document is trying to capture a high-level description of the universe of possibilities. When we get to specification, we won't try and specify all the parts of that universe. We'll need, as you said, the technical clean interface to the authentication part. And I think, as Gary is probably going to say, we might highlight the need for certain other mechanisms in addition to just an authentication service.
Right. So, but just to be clear, what we're saying is there's a delivery mechanism, which is our hand-wavy cloud picture.
Yeah.
And there's an authentication mechanism, which is our hand-wavy cloud picture.
Exactly.
And then we're going to define the rest of it.
Yes.
Okay. Thanks.
Sure.
Two hand-wavy cloud pictures, not one. Yeah, exactly.
Gary Belvin. Is under a delivery service compromise, is the server able to change group memberships?
It can, but it should be detected by the client. The same way it can reorder the message, but the client should be able to detect this.
Okay.
Any other questions? Okay, time for the protocol.
You guys are doing excellent on your time management skills. 22 seconds before. All right.
Cool. Hi, I'm John Milliken. I lead security for secret conversations on Facebook Messenger. So I'm just going to cover the... Sorry? Oh, sorry. So I'm going to cover the draft protocol that sort of we've published so far. Next slide, please. So this protocol is based around something called asynchronous ratcheting trees. And the idea is that every participant in the conversation will have some view of this tree, which they cache client-side. Then there are a series of operations which essentially mutate the tree and thus mutate the overall conversation state. And so we'll go into these in more depth, but these are some fairly obvious ones: creating groups, adding users, updating keys, less obvious, but this is for the forward secrecy and post-compromise security, and of course, removing people from conversations. Next slide. So the asynchronous ratcheting tree is a primitive that we described last year. So the idea here is that you have a Diffie-Hellman binary key tree, allowing updates to it, or most mutations, to take place in logarithmic time, so long as it's roughly balanced. The tree can be manipulated asynchronously, and we've actually proven the confidentiality of group keys just for static groups so far. So there is more work to be done on this, but we have enough proofs to be fairly confident that it's a roughly solid primitive. And so in MLS, we draft so far, we've taken it a bit further. So we've constrained the tree structure a little more. We've added support for dynamic groups so that you can add and remove members. And we've sort of tried to look a little at race conditions, although that's fairly embryonic work at the moment. Next slide, please. So to just give some intuition about how this works, it's essentially the fact that you can derive a Diffie-Hellman key pair from some random string. So as the output of a Diffie-Hellman key exchange is a random string, you can use that to form a Diffie-Hellman key. So the example we've given here is just taking a hash of a Diffie-Hellman output and treating that as a curve 25519 private key. The key derivation may differ depending on what primitives you actually use, but that's enough for us to be fairly confident that it's feasible as a technique. And this means that both key holders will know this shared key, and thus you can use it recursively. Next slide, please. And just to clarify some terminology here, just to remind you from the original drafts. So with respect to C here, we've highlighted the direct path, which is just the sequence of ancestors from C up to the root key. The root being the one node which has no ancestors. The root, by the way, is used to provide the group secret, which is used for protocol keying material. The copath is then the sequence of siblings of the path. apart from the root, of course, which has no sibling. So for C here, this is D, AB, and EFGH. And then we also have the frontier of a tree. And the idea here is that to add someone to a tree, you need to actually add a new node. And what you need to compute their path up the tree is their key itself and their copath. And so the frontier provides the copath for a hypothetical new node that will be added, that may be added at some point in the future. Next slide, please. And so the idea is, this is really fairly familiar to anyone who knows the Signal protocol. Idea that we have our keying material coming from the tree and some existing group secret. And every time we mutate the tree, we KDF that in with the original keying material. So we're able to sort of have a chain of material, chain of keys, taking in the secret data known only to the people from the tree, and the secret data known only to people who were already in the group, allowing a sequence of mutations. And we sort of term these as epochs within our drafts. Next slide, please. So to dive into the operations which we've defined, I'm going to start with operation 0, which we actually haven't defined. So creating a group, given a list of members, there is probably an option to create this directly, but in the drafts so far, we've essentially treated this as initially starting with a single leaf and composing a series of adds. In the paper, we actually do define how to create a group directly, so this should be fairly easy to implement into the drafts. And there are performance reasons to do it that way, but either way, we have something which should work in theory. Next slide, please. So the next option is what we call the group-initiated add. This is the operation whereby someone within the group wants to add someone else. And so what we need here is what we call a user init key. These are also maybe familiar to some of you as pre-keys, as termed in the Signal protocol. So the idea being a list of pre-published keys that can be used to add someone to the group. And so the group can perform a key exchange between that key of the new party and an add key, which is known to the members in the group, derived from the current epoch state. And thus, using the frontier and these two keys, derive a new leaf and thus compute that leaf's path, and subsequently the new root. We should note here that there are actually implications with this particular approach, because it does mean that everyone in the group will know the private key for this new member at the point that they join. We do have thoughts on how to improve this situation, particularly using an add key that is only known to the person adding the new member rather than known to the whole group. But this slide represents the drafts as they exist today. Next slide, please. So the next operation is the user-initiated add. So this is motivated by use cases such as conversation invitation links. So where I want to add you to the group, but I don't necessarily have your account in the service, so I just send you a link which allows you to add yourself to the group. And what we have here is another Diffie-Hellman key known to the whole group. This is actually the same add key that we had before. Sorry, okay. Which can be used to initiate this new person into the group, and then they can use the published frontier of the group as their new copath to compute the new state of the tree and then publish that. And in this instance, they have to publish their entire path now. Yeah.
Gary Belvin, 2 questions. Does this also cover the use case of the situation when a user, say, reinstalls an application?
Yes. Depending on the application, that could be done with either of these methods.
Yeah, in fact, the concrete reason why this got added to the protocol was I was trying to implement this in the context of messaging app. I was like, well, what do I do when I get a new device? So yeah, that's the same thing. So it is, you pre-publish this group init key that represents the group state for potential new users. And then when someone new pops up that wants to join the group, they just download that and initiate themselves into the group. Now, there's authorization concerns around that. But,
Yep. And one point of clarification, that means that the group init key is public.
Yes.
Okay.
And whether the application chooses to use this feature can be down to can be application specific. Okay, next slide, please. So the next point is just updating your own key. So not mutating the people within the group, but just updating your own secrets so that we can get post-compromise security. And so this is very similar to the previous operations, but involves changing your own leaf to probably a new random value, and then calculating your new path and publishing that path. This approach to confidentiality is proven within our paper on ART, because updating a key doesn't involve dynamic group membership. Next slide, please. So the next part is removing a user. There is a lot of nuance involved in this, but fundamentally, it is possible to simply issue what's effectively an update operation for someone else in the group to a key that they do not know, publish that new path, and then at that point they cannot compute the root of the tree because they do not have a leaf or a private leaf key, and thus are locked out of the group. Of course, publishing a new key for somebody else now means that you know their key in the tree, so there is nuance, and we address this a bit further within the drafts. But hopefully this is enough to give an intuition of roughly how that works. Okay, so some of the open issues. We do need to prove the security properties of this evolved protocol. It is significantly updated from art as in the paper. So there'll be lots of fun work for the academics in the room. There are a lot of logistical details, particularly with removing people from the group. As I mentioned, we really don't want situations where somebody knows other private keys in the group, as it makes it very difficult to then remove them from the group. So we need to iron out exactly how that should work. Message sequencing is obviously a fairly big issue because we need to make sure that conflicting updates to the tree don't kind of cause a split in the state. And of course, message protection, authentication, transcript integrity. The current authentication scheme in the paper is pretty similar. We need to elaborate, particularly with respect to deniability, with many asterisks, as mentioned in the previous talks. And we also may want to include some discussion of how attachments should work, as typically these are not sent within the core messaging protocol, but sent as references to some attachment stored elsewhere.
Gary, sorry for all the questions. Could you go back one slide?
Yeah.
Just so we're all on the same page, we do want to achieve transcript integrity. Is that right?
I think that's a case of maybe.
Okay.
Thus
I wasn't
far,
clear.
yeah, it's not undecided yet. Maybe a property that some people want.
Phil Baker. I was thinking through, so we're calculating this group based on the long-term public keys of the participants?
No, so these leaf keys can be rotated via this update operation. So we would expect some authentication to be rooted with the long-term keys, but the keys within the tree would not be the long-term ones.
Okay, so where does that... So is that's a transaction you've not shown, or I was...
It's a transaction that wasn't shown in these slides.
Okay, yeah, because I was just thinking about a class of attack where I create up a second group that is similar to the first, but not quite, and then manipulate. Yeah, I know there are ways that we can play that game, yeah.
Mhm.
So just to clarify on Phil's question of what keys we expect participants to have, we assume that there's basically 2 key pairs per participant. There's an identity key pair that's long-lived and used for authentication, and there's a leaf key pair which is used to contribute to the group key for confidentiality, which is short-lived. It changes whenever you send an update message for PCS.
A question, I couldn't very quickly see this from the draft, but Karthik Bhargavan Indriya. So the question is, I'm assuming that people will be members of multiple groups. And so can they reuse their same identity key in different trees, the same Diffie-Hellman keys in different trees? How does that work?
So identity keys we would probably expect to be kind of universal across their conversations. This is what you would store and authenticate via the authentication service or key transparency or whatever. The leaf keys within the conversation, we were thinking of being different for different conversations. If we wanted them to be the same, I'm sure that would be a fun challenge for you to prove security properties about, but we're not assuming that.
Hi, Matthew Hodgson from matrix.org. Why would you discuss attachments here at all? I'm failing to understand why MLS would have any opinionated position on attachments.
Actually, I'll leave it.
I mean, much like message protection, it's kind of, I agree, it's kind of a separable thing. You'll know the current draft doesn't discuss message protection at all because it seems like, once you've got a group key, use any message encapsulation scheme you like. I think the idea was in order to get a reasonably complete function here, when we were chatting among the folks who had apps, everyone had done some sort of attachment scheme because we all have, constraints on the messaging plane. And so the thought was it might make sense to take a look at clarifying that so we could have some analysis around it.
So it's an interop play in the end of it.
Basically, well, let's much like the rest of this. Let's do it in a common way so we can potentially have some common code and some common analysis.
Yeah.
Eric Scroll, I mean, just to elaborate on that, I think the sense was that, as Richard said, it was relatively straightforward once you had a shared key to build a messaging app, but that then if you wanted to have attachments, that was not immediately straightforward how to build that, and that people were sometimes built in ways that were not optimal, and so therefore describing how to build it was probably a contribution.
And also introducing these references can potentially add subtle bugs that may be non-obvious, so it's helpful to prove the security of that.
Antoine Delinia from Microsoft Research. Can you clarify why you use SHA-256? So my understanding is in your tree, you are constructing a Diffie-Hellman private exponent from a public exponent. And essentially, you are using SHA-256 to do that?
That's the example in the slides. I think
So the question is really, why are you? Have you considered using the CFRG recommended?
I think any algorithm choice that we'd make is definitely farther down the path.
Okay.
So I don't think any of it's set in stone.
Yeah. Your slide had SHA-256, so I was wondering.
Yeah. It fits nicely into a slide.
Yeah, that was definitely a placeholder thing, and where I think needs a lot more analysis. Thanks.
Yeah.
Sorry. So with Anger, I'm clarification question mostly. So you said that we can add, remove people from the group. Is the consensus amongst the group that this person has been added or removed a part of this protocol, or is it outside the scope of this?
So people should. The idea is that everyone should know who's in the group.
Okay. So that's an app level constraint rather than the protocol. Okay.
I think when we talked about this, the idea was that the system should support effectively cryptographically any single person evicting any other person, and the question of who is allowed to evict, because it's the most flexible design. And this question of who is allowed to evict was an application question that we settled by some sort of authentication access control thing.
John Lennox, yeah, One of my worries is, like you evict somebody from the group and some other member is offline and doesn't find out about it. I mean, does that now block somebody else from joining the group until you manage to reach that person, or what happens?
So in theory, this general operations should be asynchronous. So you should be able to just have a list of operations which, when someone comes online, they fetch them and they are able to update themselves to the new state of the group.
Okay.
In terms of two people doing conflicting operations at the same time, based on based on the same state, doing different things, that's sort of an open issue.
Yeah, I mean, I think if you've got 50,000 people in the group, you're going to have things happening at the same time.
Yes.
This might be appropriate for a little bit later, but it just occurred to me that the size of the tree only grows over time. Is that correct?
Yes. So we justify that sort of with removing people never makes anything worse. All it means is that the tree is not quite as optimal as it could be for the new set of members.
Can you rebalance, Ben Schwartz, can you rebalance a tree that contains zombies?
Maybe. Yeah, so we haven't looked into rebalancing operations. Probably the most obvious way to do that would be to just reuse blank spots when you add new people. But we could potentially look into rebalancing operations if this is a operational concern.
So specifically, I mean participants who have not removed themselves but who are unresponsive.
So we did discuss it. I don't know if it reached the drafts actually, but
yeah, I'll repeat for Nadim. Yeah, as Imad noted, that is an explicit concern we need to address here, is having long-term unresponsive nodes, and we need to have a way for the server to evict them.
So Ben Schwartz, I think my concern here is that it's not just about evicting them, but if you have a long eviction timeline, as noted before, then if you can't rebalance the tree until you've evicted all unresponsive nodes, then you may never be able to rebalance the tree.
So the word rebalance is a little odd here, because the trees that we're using here to keep the math simple have a fixed structure for the number of leaves. Following on the CT, use the same math as certificate transparency. So there's not really rebalancing going on, but whether a leaf is occupied or not at a given time.
Okay, then does this create a scalability problem? Does this mean that I have to use size large trees for all groups of all sizes?
So it does mean that if at one point your tree contained 50,000 people, and now and after a sequence of removals, it now only contains 2, then you've got a pairwise group with a tree depth of 16, which I mean, tree depth of 16 is still computationally feasible in most situations, but it is suboptimal, and we basically consider that as a fairly unlikely scenario to be too frequent.
But also because this isn't a fully baked protocol, it would be something the working group would decide and discuss about in the working group. So it's good that we point these out, but doing it on the fly engineering it now is probably not really a good use of our time.
Yeah, I can believe that the math will work for a group of 50,000. I do not think that you can have a messaging group of 50,000 participants. I mean, your system is going to fall apart for other reasons before that is reached. So I wouldn't be.
Okay, thanks, Phil. Noted.
Is it in scope to be thinking about, Ben Kadek, sorry, is it in scope to think about the forward secrecy of messages generated by a client that is offline racing with removal from the group, so that the generated messages would be generated to a key that is known by the member that is getting deleted?
And
feel free to tell me that's out of scope for right now.
I think probably out of scope, at least so far as now. And I think it's reasonable to consider that if a client believes that someone is in the group at the time it sends a message, it is reasonable for that person to receive the message. But that's probably a sort of fine point to discuss later.
This goes back to transcript integrity.
Yeah, I think what I would say is that it is definitely in scope for the architecture document to have a very clear, crisp, detailed description of the security properties, which is probably going to hit some of what you're talking about.
Yeah. Cool. Yeah. Yeah, I think this is fairly clear.
So half of us used orange and half of us used green, so apologies to your retinas. So I'm Catriel, I'm from Oxford. I'm basically here to say hi. I am an academic so far. There's a few of us around. We're interested in working on this. It seemed to work pretty well for TLS. So we hope we can do similar sorts of things. However, since I don't very often get to represent all academics ever at the IETF, I'd also like to say, let's see. Dually C was great. MLS visibility draft is coming soon. You see, I can say that because I'm only a student. That was a joke. So there's a few researchers and academics involved in the working group, either on the mailing list, coming to meetings, and so on. Many of them are here, so please come talk to us. There's a fair amount of experience. So Karthik, you already heard from, if you were at SAG this afternoon, works on TLS. Cass, who is my supervisor, also worked on the TLS analysis. Benjamin, who's sitting there, F-star, NSS. So we have some experience looking at protocols, although there's a bunch of new and interesting challenges in the messaging context that you've heard about that we look forward to looking at. This is related to projects like MyTLS, the TLS 1.3 work, the 5G work that my fellow student Martin was working on, and so on. Next slide, please. All right. So just to give you an update on what analysis there's been so far. So John put up a link to the ends-to-ends encryption paper, which we wrote a few months ago. And that really defines the ratcheting tree primitives that you got an intuition for. So if you want more formal definitions and if you enjoy reading conference paper formats, you can check there. In that paper, we spend a fair amount of time looking at security properties and looking at them fairly formally. So this is capturing secrecy and authentication of messages in a mathematical cryptographic proof, pen and paper way. This is also, we define properties like agreement on members. Those we punt on a little bit, but I can talk about that offline. And the other thing to say here is that we have a fairly good understanding of what post-compromise security means in a formal sense. And so we do indeed define post-compromise security for the protocols in the paper. I guess the takeaway for that is that the ratcheting tree construction itself is relatively new, but we've already started to analyze it. There's plenty more to do. So a little bit more about what we actually did. We did two sort of separate things. So there's a key tool you can think of, as it were, which is the ratcheting trees. And the first thing we did is we abstracted away from the concerns that people here will really be interested in, things like message formats, dynamic groups, how you add people, what exactly it means to add people, how you deal with race conditions, and so on. We abstracted away from that a little bit and just looked at the core cryptographic primitive. This is unauthenticated for now. And we gave pen and paper cryptographic proof, which is a security reduction. So we reduced the security of that to the Diffie-Hellman assumption. This is a fairly standard proof technique. It has its pros and its cons, but that's what we did. And that's really looking at the core ratcheting trees. Of course, that's not nearly enough if you actually want this to be secure or usable. You also need to make guarantees like, if I remove somebody from a group and then send a message, they didn't get it. If the group has people added to it, then you have forward secrecy in the ways you were hearing about earlier. So the other thing we started to look at, and this is very early work, is doing symbolic analysis using mechanized tools. So we looked using the Tamarind prover, but I hear there is also ProVerif work happening, perhaps even right now, depending what's on that computer screen. Next slide, please. So what do we want to contribute going forward? We have some formal definitions of fairly low-level properties. We're going to want to provide very precise definitions of all the properties you saw earlier. And this includes things like if you have a state recovery mechanism for, I dropped my phone in the toilet, but honestly, I really want to be in this group. Please put me back in. The interaction of that with confidentiality is subtle, but we think you could express it. You'll want something like, well, you got told that this person is claiming that they have lost their device. You can deal with that as you will, but we can encode that into a formal property. We ideally want the properties here to be fairly general. We don't want to hard code, this is how WhatsApp would use it, but again, that should be fine. Then, of course, after specifying the properties, you want to verify that whatever system, if a system ends up being designed, whatever system gets designed actually meets them. So that means also low-level proofs if there are any significant changes to the ratcheting tree mechanism. And then looking at the protocol level, looking at things like proving authentication, making sure that only people in the group can add to the group if you want that, or only authorized people can be added. Looking more at the threat model where somebody in the group is malicious, which has a lot of subtleties, but we think you have some guarantees. And looking at proofs for the dynamic group case. I hear there's this magic tool that lets you write verified implementations, and it just works. So hopefully that will be an easy addendum to all of this as well. Next slide, please. That's about it. So really, I don't have much to say at the moment other than we're interested in analyzing things. We hope to follow the TLS process. So we hope that drafts will be posted, that we'll be able to pick one, make some comments, maybe make some comments that help the protocol analysis. And yeah, we're working on it and we're still going.
Karthik Bhargavan, Indria. So one thing I'd like to mention here is that, I mean, things like post-compromise security and forward security, it's forward secrecy and so on are properties that sort of just pop out of protocol proofs and protocol verification. We understand them quite well, so we state them, but they may actually not be the most intuitive ways in which application developers and the people who are actually going to use MLS may want to think about the security goals. So this is a call out to everybody in the room that if you have an intuitive notion of what are the goals that you would like, state those and we can figure out how to code them in terms of these highly technical definitions, which are useful for us, but maybe may not be so intuitive for everybody.
This is particularly true in the group context, where if you're very used to one-to-one messaging or one-to-one communications like TLS, it turns out there's a whole lot of other funny properties that pop up when you're worrying about, say, 3 people in a group. A simple example there is if you have a shared key with one other person, then if you get a message encrypted under that key, you know they sent it. If you have a shared key with 2 people and you get a message encrypted under that key, you don't know who sent it.
Is it true ProVerif is much better than Tamarind?
ProVerif is useful in some limited scenarios.
Okay, before we get to the charter text, I'd like to ask a few questions just to get a sense of the room. So how many people here have read the protocol draft? That's a good amount. How about the architecture draft? Also a good amount of people. How many people have read the formal analysis paper? More than you would expect, yeah. Well done, yeah. Okay, and of people who are working on messaging apps, who's interested in implementing the protocol or a derivation of the protocol as written? Yeah, quite a few people, yeah. So Some of the people who have raised their hands, if you're willing to go up to the mic line and state what messaging app you're working on.
The only caveat is obviously this does not mean that you will absolutely positively do it anytime soon. It's just that you're working on it. So,
right, this is to express interest and to express interest relative to a specific application and affiliation.
So I'm Imad Omar again. I implemented the end-to-end encryption for Allo and Duo in Google. So I'm definitely looking for something like this to implement.
Jonathan Rosenberg with Cisco, and we're looking at this for Cisco Spark.
This is Eric Rescorla. Sorry, this is Daniel Kahn Gilmore. I work on an email application, which is my preferred email client, which is called Not Much. And if this can work in an email client, I will try to put it in the email client.
Gary Belvin, I work at Google. I work with eMod. I'm working on an open source authentication protocol called Key Transparency, which we hope would be useful to this.
Matthew Hodgson, again from matrix.org. I think we were one of the prior art mentioned on Richard's slides, thank you, on the Ohm and Meg-Ohm ratchets that we did. Crypto is pluggable in Matrix as a decentralized communications protocol, I guess addressing a similar problem, but the next layer up the stack at the application level. And we're certainly interested in MLS as a successor to the Ohm and Meg-Ohm stuff we're doing today.
Hello, I'm Dave Cridland and I work for a company called Shorevine, but I also have another hat. So I also work for the XMPP Standards Foundation, and there's substantial interest in end-to-end cryptography there.
Hello, it's me again, John Milliken from Facebook. We're interested in this for secret conversations in Messenger, and there's one of the names on there on that list is from WhatsApp. They are also potentially interested in this.
Hi, my name is Rafael Robert, and I work for Wire, and we're interested in continuing the work on this with a go to integrate it into the product at some point.
Philham Baker, Komodo Security Solutions. Yeah, we're also interested in it. We have a client.
Is anybody on the Jabber commented with respect to this?
I'd also like to, so I'm Nadim Kobesi, I'm responsible for CryptoCat, but I'm also interested in this. I've been working on this, on secure messaging for 8 or 9 years. This is something that has grown from like a niche experimental thing to affecting the most immediate way that billions of people communicate. We need a standard on this. We need something open. We need something that can be absolved of any sort of human notion on whether we get to implement it or not. To me, this is existential, and I would like to see it happen. This is extremely important, and as human beings, we should be doing this in an open, standardized way. CryptoCat doesn't matter anymore.
So we got Aaron Kret from the Jabber Room saying, I'm here from WhatsApp, and we are also interested in this.
Okay, so double confirmation.
That's to all the people that at the reception that they said, well, we tried this before and it didn't work. Who's here? All right, so now we're ready for some eye charts. We're going to read the charter that was posted to the list. There have been some comments and they've been amended. It's at least 4 slides and 16-point font. So as we walk through this, do you want to read the whole thing?
Is that the first one?
Yeah, we'll read it through, and if there are specific comments, we want to be very clear as to what the correct charter text is and whether or not there are questions. Okay, so I guess we'll go slide by slide. I'll do the first one. So several internet applications have a need for group key establishment and message protection protocols with the following properties. Asynchronicity. Keys can be established without any 2 participants being online at the same time. Forward secrecy. Full compromise of a node at a point in time does not reveal past group keys. Post-compromise security, full compromise of a node at a point in time does not reveal future group keys. Membership authentication. Each participant can verify the set of members in the group. Message authentication. Each message has an authenticated sender. Scalability. Resource requirements that have good scaling in the size of the group, preferably sublinear. So are there any comments on or questions about this first line of the charter?
Can you bring it up again? This is a terrible quibble, but your bullet points aren't parallel construction. Well, all but the last one are sentences, and the last one is a phrase.
I felt that when I was reading it.
Can you show the slide again? Antoine Deligne from Microsoft Research. Seems to be a big problem in that slide. I don't see where you actually state that the messages have to be confidential and not revealed to anyone outside the group.
We should add that, yeah.
Oh, that's good news. I'm quite happy.
It's a lot easier this way, though, don't you think?
Okay, so I strongly suggest that the charter is changed to include confidentiality of messages, in particular with the latest discussion in the Quick and TLS working groups.
Visibility.
Okay, we'll note later, then we'll see if we can amend this with confidentiality, which seems like an obvious good property.
Ben Schwartz. This is definitely a quibble, but full compromise of a node does not reveal future group keys. Works for some definition of full compromise that is read-only. If you can modify the client, then you can have it tell you everything in the future. So that your definition of full compromise is a little weaker than mine.
Sure. This should be clear. We should be clear that this is full compromise of the cryptographic components that make up the identity, rather than the application itself.
I think that could be a little clearer.
Send text.
Dan Harkins. Message authentication, does that mean that if this is in the charter, that deniability will not be something we work on?
No.
No? We still can work on deniability?
Yes.
Okay.
Yeah, so the concrete property you want is that members of the group know which other member of the group sent the message. That does not necessarily mean they can prove to a third party who sent it, though it might mean that. It's a subset of that.
Ben Kaduk wearing the ghost of my ACE working group chair hat. So the text up here at the top about group key establishment and message protection is perhaps more generic than you want, in that over in ACE we've had some very contentious discussions about keying for group key establishment for IoT messaging, which I assume you do not want to bring here.
The later paragraphs tighten it down, so to speak. So when I read this, it's like internet applications, does group key management, and then the next set of paragraphs is like for messaging and that kind of stuff. So hopefully that'll address it.
Phil Baker, the membership authentication. I'm pretty sure that if I have a group that's larger than 1,000 people, I'll be wanting to keep the group membership confidential. So I'm not sure that that is actually a requirement. That is a feature of the protocol architecture you've chosen, rather than something that everybody is always going to require. The other thing I'm a bit concerned about is if we don't actually do any form of interop testing, how do we actually know that protocols that say that they're doing MLS actually are doing MLS? And we may well have an issue with somebody not doing it right and then having the protocol tainted by their incompetence.
I think we can deal with the interop problems later, because they can test 2L implementations without having to test the apps. It can be done.
Colin Jennings, I say this just because it's a charter issue. I think we do have applications where we're interested in very large video conferences where the group of people is known. So I think there's, I think there's use cases both ways, Phil, so I'll try to say.
And we're getting a little far afield, but to Phil's point about interop testing, I would say you would do MLS interop testing like you do TLS interop testing. It's tied to a given transfer. You're going to do TLS interop testing over TCP, and you'll verify that you can pass some data over it. But what you're really testing out is the key negotiation and encryption. So I think I would expect that the MLS stacks would be able to interop in the same way, where you can generate messages that negotiate keys and verify that they negotiate the same keys.
What I'm getting at is that we may need to have some draft that tells you how to dump out the interop stuff just so that we can do it. And we shouldn't hardwire the charter to say that we can't do that.
Absolutely. All right. Thank you for taking notes. Whoever's taking notes, so we can put this back in. Here's slide 2. Several widely deployed applications have developed their own protocols to meet these needs. While these protocols are similar, no two are close enough to interoperate. As a result, each application vendor has had to maintain their own protocol stack and independently build trust in the quality of the protocol. The primary goal of this working group is to develop a standard messaging security protocol so that applications can share code and so that there can be shared validation of the protocol, as there was with TLS 1.3. It is not a goal of this group to enable interoperability between messaging applications beyond the key establishment, authentication, and confidentiality services. Full interoperability would require alignment in many different layers beyond security. Example, standard message transport and application semantics. The focus of this work is to develop a messaging security layer that different applications can adapt to their own needs.
My comment is that there's double spaces and single spaces mixed together.
I'd probably introduce that. All right, so I'll just read the next one too. In developing this protocol, we will draw on the lessons learned from several prior message-oriented security protocols, in addition to the proprietary messaging security protocols deployed within existing applications. Some of these include SMIME, OpenPGP, Off the Record, and Signal. The intent of this working group is to follow the pattern of TLS 1.3 with specification, implementation, and verification proceeding in parallel. By the time we arrive at RFC, we hope to have several interoperable implementations as well as a thorough security analysis. The specifications developed by this working group will be based on the pre-standardized implementation and deployment experience and generalizing the design described in Draft Omara and Draft Barnes.
There's a grammar issue there.
I think we're going to put this on GitHub and then we can have it out. Finally, note the consensus is required both for changes to the current protocol mechanism and retention of current mechanisms. In particular, because something is in the initial document set does not imply there is a consensus around the future or around how it is specified. And then the milestones, which are pure bull. So it's May 2018 for the initial architecture to initial working group documents to adopt the messaging protocol. I mean, if we're going to do what we did in TLS and build in like delay for the researchers to crank their Tamron proofs, I would normally slip all these dates to the right, all the 2019 dates to the right by 6 months. If we're going to add in time for the security guys, we're going to add another 6 months to that, right? Because I think it's only fair that if we get the protocol done and they find something, we're going to change it.
And so the first milestones are fine. In fact, the first milestones are really fine, right? It's the 2019 milestones, which yes are like science fiction. So I mean, I would just like slip those to 1/120 and call it a day.
So the nice thing about picking these dates is they're all wishy-washy. All what happens is that we start to get nasty grams from our AD or from the data tracking center to say, update these things. So we can, if everyone's basically kind of happy with the first two, I think we're okay. And then the last three, we'll just add a year plus.
Yeah. I would just suggest you negotiate those with your area director.
Fair enough.
If you can find him. So otherwise, this looks pretty good.
That's you.
Ben Campbell. I think I know the answer to this, but just to clarify, when you said the milestones were bullshit, you meant just the dates. The stuff on the right side's okay, right?
Yes, just the dates.
And I appreciate the grammar fixes pointed out by people in the audience. This is in a Google Doc that was sent in a link to the mailing list a few weeks ago. So I would really appreciate edits.
I think that Nick and I will get together and throw up a GitHub where we can start dumping stuff up there so that you guys can edit it. All right, scoping questions.
Okay, so we have a couple questions here about the scope, and we wanted to make sure that folks in the room are generally in agreement about several questions. So first of which is, does the scope sound reasonable?
Yes.
Yes.
Does anybody in the room think that the scope that was laid out is not reasonable? If so, get up to the mic.
It's always one.
Sorry.
It's always a set.
Sorry, DKG again. All of the discussion that we've had here has been about the key management, and slipped into the charter is about message protection. And so I want people to be conscious of the fact that we seem to be chartering ourselves to do another message protection document or set of document or work within the IETF. We have two already, OpenPGP messages and the cryptographic message syntax. It sounds to me like we're kind of talking about a third. And all of the presentation and all of the interesting discussion that we just had didn't really mention it. We just kind of slipped it in at the end.
So I don't know what other people think. Speaking for myself, I've been assuming that this would reuse one of the existing formats, Jose, or Bose, or whatever we have. But if you think about the relationship between Jose and Cot, right? Where Jose and Cot, where Jose is like a generic message protocol, and then Cot specifies these are the shit that has to appear into it. There's certain things that have to appear in here to make the thing work, like key identifiers and maybe like sequence numbers and stuff like that. And I think it's effectively a profile of one of those things. That maybe I'm wrong. It doesn't have to be that. That's what I have in my head. I don't know. I guess my presumption would be that's. I guess I would like. Maybe there's some situation in which that's not appropriate. So that they're working with have the flexibility to make it a different decision. But
so I actually had a slightly different expectation than what Ecker just described. I was envisioning message protection to be something like the TLS record layer, the TLS ciphertext struct, because this is a rather more limited context where everything is pre-negotiated. So you don't need all the indications that you might need in say JWE or comparable Jose object. So I think that's about the universe of things we're talking about. Either reusing something, if what we need is simple enough, defining something lightweight that makes sense only in the context of this protocol, or reusing something generic if that makes sense. That's I realize it's a little wishy-washy. Yeah, that's what the charter says.
Let's go back to the charter. So this point goes back to the DKG. The very last line in the charter is what your question's about, right?
There's a couple of sentences on previous slides.
I think it's the very first line and the very last line.
Okay.
Yeah. Okay. Please.
Yeah. So if I may sort of beg to differ on that actually, and Jonathan Rosenberg. So this is sort of an interesting protocol we're defining in that it's not actually meant to provide interoperability across different vendors' products. So I see what would be the point of specifying the actual message protection technique, because it's never meant to interoperate. In my view, the main objective here is, it is to provide something that has a correctness capability, and that's it. And so that we can say it works, and we can do some testing against the test shim with some implementations just to make sure yours is correct. But besides that, none of these things are planned to interoperate. And so I think we should do the minimal amount that delivers correctness and no more.
No, I certainly agree that correctness and having verifiable security properties are the targets here. But I think to Phil's point from earlier, in order to really verify that we have something interoperable, I think we need a syntax so that we can test around something. And maybe we can plug into JWE yeah, but, well, let me frame this differently. I think in order to get something that is sufficiently detailed that we can verify the security properties we're going to want to verify, authenticity, transcript integrity, etc. We're going to need to specify this whole, you would need to say the message protection format must provide this and this and this and this and this, at which point you might as well define a syntax that does those things.
Phil Baker. I disagree there. I think that we can have the output of the interop harness simply be the key values that you're going to use. Because, you know, the output of this is ultimately going to be a master secret that changes with state changes to the tree of members. The reason that I would like to keep this out of this group is that the obvious next standard process, which will be an apps process, will be to propose a standard messaging format. I mean, you know, we are a standards body. The internet needs an interoperable messaging platform that's based on an open standard that anybody can set up a server that works like SMTP. And that is something that the IETF should be doing. But the fact that we have this group doing key negotiation shouldn't block the apps area from doing that part of the task. And the fact that vendors would rather we didn't come to an open standard shouldn't stop that either.
So I guess I'm going to disagree with the claim that all we need is the key values. If you want to provide transcript integrity and you want to provide, group integrity, you're going to need to standardize like specifically the contents of the messages. And so, like, if people really feel like they don't want to specify whether it's Jose or CMS, like, you know, I guess we could define an abstract description of what the messages had to contain. And the messages largely are AAD blocks containing some crap. But like, I think it is imperative that this describe like what the property. I mean, so maybe a way to skin this is we describe this sort of abstract, message switch service as abstract authentication service. And similarly, you could say, well, there's an abstract messaging service whose property is it takes a key and a bunch of metadata and and some data, and it spits out like a blob. And then on the way in the door, it takes a key and a blob and spits out metadata and some data. And if people want to like do that, like that seems fine. But that's a minimum to make the damn thing work. I mean, it's sort of like almost baffling you have to say that because like now you're just like, okay, we're just gonna like. I guess, well, now you can like, okay, I want to CBOR or JSON encode the metadata before like I stuff it in the AD. But like, if that like makes people feel like warmer, I'm like totally fine with that. But I think that's what has to happen.
Dave Cridland again. Just in answer to, well, mostly Philip, but partly Eka as well. There is already an interoperable messaging system that was designed within the IETF. And you can set up your own. Well, there's several actually, but XMPP exists, and the getting of a message from one place to another is done and dealt with. That's an easy job, and you can set up your own server, and you can do all of this. The bits that the XMPP world need, and proxying from that, the apps world will need guidance on is I can tell you what format the messages inside the encryption should be. I can tell you what format the messages outside the encryption should be. I cannot tell you in what order to do the signing or the encryption, and nor would I try to tell you. If you guys all say, well, you can negotiate all these keys and then you do ROT 13 or even double ROT 13 for extra security, that's fine. I'm just going to go along with that. But on the other hand, I do know what needs to go inside the messages. I do know what needs to go outside and how to transport them around the network.
Matthew Miller, I think I'm probably going to echo a few of these other ones. I think we can find a boundary here on what we need to do, that we can come up with interoperable implementations. As long as we've got inputs and outputs that we can coalesce into a way that we can do an interoperable test, I think we'll be okay. for what we're looking at trying to do. And, whether that is Jose, whether it's we start with the TLS structure and find some mapping that works for the testing framework, I think any of those are equally valid at this point. In fact, I think this is almost worth just punting a little bit further on and just saying, we will work on something.
So the sense of the room I'm getting is that there's not a demand to define a message syntax in the application sense, but potentially a definition of what the ciphertext format would be.
Colin Jennings, it seems that we're debating almost a bike shed issue here, which is at the very bottom of our thing. We have some stuff that falls out into a container, and we're talking about whether we need to define no container, an abstract definition of container, pick a container, or point out that this maps to different containers. And most of the people who stood up at the mic 10 minutes ago are all going to map this to different containers. Let's just leave this to this working group. This has really changed the work in the charter in any significant way. Let them figure it out when it gets going. It's not going to be a big deal. So I think we should just ignore this topic for the point of chartering.
That was actually going to be my point, was that if this was something that somebody really felt like they were going to fall on the sword for before getting up and chartering, they should get to the microphone and state their case. Because I kind of felt like it wasn't that way.
No. I just want to be clear. I just want to be clear because I don't want to miss it. Jonathan Rosenberg. I don't want to miss expectations around working group members around different goals. I'm sort of hearing some people want to build interoperable messaging implementations, and that certainly requires you to do an extra layer of diligence. I think even at the core, how you specify this thing when your goal is correctness and not interoperability at any layer of the system is probably pretty different. So while I'm not going to fall on my sword on this particular topic, I just want to make sure we're aligned that the goal is correctness, not interoperability. And I saw interoperability in the charter. I do.
Ben Kaduk, this is somewhat overtaken by events, but it is possible to use phrasing like giving consideration to existing IETF technologies, including COSE, JOD, CMS, etc.
Next question.
Okay, the next question is, are the security boundaries presented suitable for a security analysis? And if somebody disagrees, please step up to the mic. Or so if someone says no.
I would actually like the chairs to take hums for these just so we have them on the record.
Okay.
If that's okay.
All right, so let's do a hum for this. Please. So, okay, we're going to have a hum for yes. Are the boundaries presented suitable? Yes. And then a hum for no. So, hum now for yes. Hum now for no. Okay, I think that's pretty clear. Let's move to the next one. This is based on a question raised on the list. And do we agree that the application layer interface is the correct place to enable visibility requirements should they exist?
Okay, what does that mean?
Yes. So I'm reading this as we're not going to do anything to enable visibility. Is that what that means?
Yes.
Well, yes. The set of parties that can decrypt a message is determined by the key management protocol as the membership of the group, and there's no provision for decrypting beyond that.
Let's do hum for this as well. So, yeah, let's change the phrasing to what Richard said. So, the statement is only the members who are agreed upon within this protocol to be able to decrypt messages. That's okay. I'll rephrase that. The only parties able to decrypt messages are the parties who are authorized by this protocol.
Given we have a BCP that basically says this will all do, why are we even discussing this one?
Abundance clarity. Okay.
Okay, Jonathan Rosenberg. I'm going to sort of repeat my prior comment. I'm like, since we're not specifying a protocol, if I want, I could build my application on top of it that like emails the keys to everyone in the universe. I mean, no one will use my app, but like, okay, like why do we even specifying this?
We're specifying that it is at the application
Right.
layer.
What I'm understanding, what I'm assuming is that the purpose of this charter is to rule out of scope, say an extension like the RHRD extension that's presented on Monday. Is that what the point of this clause is?
Yes.
Yeah, you already have a multi-party thing.
Okay, so let's have a hum for this. Hum yes for the only parties to decrypt the messages are the ones authorized to decrypt, and we'll have a hum yes and then a hum no. So hum yes for no. And hum no.
Just fucking with the guy. It's a meeting question.
Okay, one hum in the back.
You can totally do that. We didn't define encryption.
I guess then everybody's authorized to decrypt.
So Martin Thompson, we're not bashing the words here because this is a non-statement. But we all understand, right? Good.
Yes. Okay, so let's do the next one. So this is a question about whether or not the two documents that most of the room has read, constitute a good starting point for a working group. So hum now for yes. Hum now for no. That's pretty clear. And now the final question about should the IETF do the work is this proposal flexible enough for the common use cases of secure messaging applications? And are there no clarifications on this? Then we'll go straight to the hum. So hum for yes. Hum for no. So for the people who hum no, do you want to make your case in that this is not flexible enough to support the common use cases?
I have a bunch of use cases that I think are not going to be covered by this, but that's fine because I think that we will discover them as we go through the work, and we will need more than one key agreement for multi-party communications. The case where you don't know the other parties in the communication is a real one. The case where you have the communication controlled by one party is also real. When you have n greater than 2 in the conversation, you're going to have a lot more degrees of freedom. And the idea that one set of requirements is going to fit absolutely every application is just not going to fit. So
the statement is common use cases.
Yeah.
These are common use cases?
I will agree that it is flexible enough for common use cases, but not if you put the definite article in there.
It's similar to Philip. I think if you actually add one word into that, then it will stand, but without that one word, it will fail. I can give you lots of common messaging applications where this won't work. Mailing lists won't really work. The mailing lists that we use in the IETF, for instance, those aren't entirely uncommon. There are a number of other cases, message boards, anything along those lines, and these are all asynchronous messaging applications. So if you put in the word synchronous just before messaging, then you're covered.
Instant is the word you're looking for.
Well, okay. Well, it depends on how you look at it. If at any time your messaging application relies for its utility on access to historical information for people, then that fails. Now, typically, I describe those as you either have synchronous messaging applications in as much as you expect the other person to get the message in a timely manner, or else it's asynchronous, where you expect people to look at messages out of order, massively different massively different times.
Okay.
As Jim Gettis said to me, this is pinball. You win, you get to play again. So I'm saying that after we've done this one, I think there's another game we want to play. I'm not saying block this. I'm saying bear in mind that this is not the only way of skinning this cat.
Okay, I think that makes things clear.
I don't think we need to parse out right here whether exactly the set of use cases that are addressed. I think the critical question is there a compelling set of use cases that this addresses? And for me, that answer is yes.
Okay, so let's hum for that then. Are there a set of compelling use cases for which this protocol is useful? Hum yes. Hum for no. Okay, so I think that's a lot more clear.
So this is not awkward, but just nitpicking. These are all great questions, but the one question you haven't asked is, should we form a working group in this area? And oh, I didn't see that. Those weren't there.
These are the last successful BOF
okay.
questions. So we kind of led you down the garden path here a little bit on some of these. So the first one is, is the problem sufficiently understood? We've had a little bit of debate here or there, but basically it kind of seems like people have gotten to the point where they're like, we're okay. So we're going to have a hum on that actual question. So please hum. I'm going to do it twice, right? Please hum now if. Please hum now if you don't. So please hum now if you think the problem statement, if the problem is sufficiently understood. Please hum now if you think the problem is not sufficiently understood. Okay, so that's clear. Please hum now if you think the problem is tractable. Please hum now if you think the problem is not tractable. Clear as well. I'll let you do the last three.
Okay, so the third question is the IETF, that's the this in this case, is this the right place to address the problem? Hum yes. Hum for no. Okay, so these are not hum questions, but who is willing to author specifications? Okay, great. And
18 or so for the notes.
And the more important question.
No.
We'll take a photo.
So the more important question is, who is willing to review specifications?
Even higher number.
Your hands up there.
Come on. 30.
For you,
If you went to the mic, you got to review.
Yeah, exactly.
And that's it. Oh, so I guess the real question is, like, do we think that this is a good enough thing to start a working group for? So let's do a hum for that. Please hum now if you think we should form a working group. Please hum now if you don't. That was pretty darn clear. We're still gonna work on the charter text a little bit, obviously, but I think we're in pretty good shape.
Professor of Library Science.
I will cut you.
So one more, please, so I can try to make my bag lighter. If your name's up on this list in yellow, please come up here.
Well, some of those people already got theirs, didn't they?
They are, but I could change their name.
Yes. Skenazi Wood. I know you're rocking their shirts.
No, these are Americans. All right.
Hey, Deb.
Yeah, all right, cool. So what is this? Stop this first bullshit. All right, so where is? Come on. One more.